Hello everyone in CIS-115. We are finishing up Module 6 this week, and our topics for this particular lecture and this week are linked list, cryptocurrency, and cryptographic hashes. And they're all tied together through the concept of a linked list. So we don't get into this material on linked list in depth in the textbook, but a linked list is a special type of data structure. Feel free to look over the material, but you're not going to be tested on linked list per se. So you may have heard of cryptocurrency, and Bitcoin is just one particular type of cryptocurrency. Why we would be talking about Bitcoin in the context of this class is because it utilizes a list, and this chapter is on Python list. So one of the more interesting things in cryptography, and it's an intersection of math and logic, is hashes, and I'm going to click on this link to cryptographic hashes so I can point out a couple things to you. A couple key things about cryptographic hash here are bulleted. First one, it's deterministic, meaning that the same message always results in the same hash. Why is that important? Well, there's something called PGP, which stands for Pretty Good Privacy. It is a way that you can sign your emails, put a little digital hash signature at the bottom of the email. Why would you want to do that? Well, when you send an email to someone, it's actually public. 4 billion people on the internet could see that message as it flies across the internet, sometimes across as many as 14, 15, maybe 20 different networks, and it's wide open for anyone to see as it traverses across the internet, where over 4 billion people are there. So it's actually worse than that, though, because anywhere along the way across any of those networks, someone could alter your email. Yeah, that's right. Change the words and, change the message. Person at the other end has no way of knowing that the message has been altered. So you could, have all kinds of things happen with 4 billion people on the internet. So this is where cryptographic hash comes in really handy, as in this first bullet point where it says that the same message always results in the same hash. So we could put that hash signature of what we wrote at the bottom of our email and sign it with a public key, as Pretty Good Privacy does, and anybody that gets that message could quickly run it through the PGP program and tell whether someone has altered the message or not by looking at your hash. So here's another bullet point. It's infeasible to generate a message that yields the same hash value. So no two messages would result in the same hash, and that's this bullet right here. And when you alter just one little thing in the message, whatever you're taking the hash of, the hash looks completely different. So the key to these cryptographic hashes are they're a one-way hash, and you see I highlighted that. You cannot work backwards from the hash and tell what the original message was. That's what I mean when I say it's one way. Where does that come in handy? Well, Windows, have you ever wondered how your laptop knows your password is right? Do you think that the laptop stores your password somewhere? Well, actually, Windows does not store your password. It stores an MD5, a special type of MD5 hash that the hash of your password. So if someone hacks your Windows laptop and gets into the SAM database that stores the security information, what they will see is something that looks like this purple box here, or pink, whatever you want to call that color, and that's a hash of your password. They can't take this and work back to your password. The only way they can determine your password is by something called brute force, and that's talked about here, where we basically try everything against this hash, every combination of every letter, until we find something that matches that hash. So it's basically brute force. So Windows does not save your password. Windows saves a hash of your password. Windows does not know your password. Windows can only tell you what is not your password. And so it knows that you've provided the right password when it takes that password, runs it through this hash program, and gets a match against the hash that it has saved. That's why we say it's a one-way hash. So let's look at how to create a hash of something. Now, there are a lot of different hash algorithms. If I go back here, you can see that here's some listed. MD5, which is what I said Windows uses a special version of to store a hash of your password. There's a SHA-1, there's actually SHA-2, SHA-3. Why do you think they came out with these later versions of these hashes? Well, they found a collision. That's what everybody keeps trying to do. They found two things that yielded the same hash. If they find that, it's kind of like triangulating your location. If just one person takes a bearing on your signal, your radio signal or whatever, then they can draw a line from that bearing, and basically that goes on forever. They don't know where you are, they just know what direction you're in. But if we have somebody else 5 miles away that takes a bearing against your signal, and then we take those two lines and draw them out, where they intersect, we can tell where you are. So That's what they try to do, breaking these hashes. When they find a collision, they can break the hash. So as folks find collisions, they come out with newer versions of these hashes. So let's go and create a program to take a hash of something. So I clicked here. Let me go back so you can see number 8 on the checklist. There's a link to the Bitcoin and blockchain material. And so when I click on that, we'll come back to this video. You'll have some homework questions and things about this, but let's go down to this code right here. Okay, and I'm going to download this. This is the code that I've written to compute a SHA-256 hash, which is a pretty strong hash. So let's save that down to Module 6, Hashes Lecture. Save that Python code down. And there it is. I'm going to open it up with Tani. Alright, so a couple things to note here. This code right here that I have highlighted, actually, let me redo that. This code right here that I have highlighted is doing the same thing as this one line of code. Sometimes when you put too many things on one line, people have trouble understanding it. So I've broken it down into one step at a time here. But just so you know, this code right here, these 4 lines of code, are doing the same thing as this one line of code. So when we run this, we're going to see the hash print out twice. I have a lot of folks that when they're trying to do homework or the exam and compute a hash, they'll actually take the output from both of these, and so they have a double hash, and you'll see that here in a second. So let's talk about what's going on. This is taking a string in that's called proof of work. It's creating a byte array, which is a special kind of array. It's converting this sentence into this sentence right here into a byte array. It's taking the byte array and passing it to this hashlib SHA-256 function, and we're calling the hex digest of it, and that's actually giving us our hash that then we're printing. So you could do the same thing with one line of code. So let's talk about what this one-liner's doing. This, when we put a little b in front of the quotes around a string, it tells Python to convert this string into a byte array. Okay, so we're taking a byte array of that string, we're passing it to this SHA-256 function, and we're getting the hex digest of that out. And then we've got all that wrapped in a print, so we're printing it. So here I'm going to run it, and you can see this right here that I have highlighted is from that print. This right here is from this print, and you can see that they are identical. If you look down through here, nothing has changed. Now I'm going to alter something in this lower one so you can see how sensitive this is to any alteration. I'm just going to change the proof. You see how that's a capital P right now? going to change that to a little p and run the program again. Now here's the lower hash with the little p. Does it look anything at all? Does this one that I have highlighted look anything at all like the original one that's coming from up here with the capital P? The whole thing changed. That's how sensitive this is to any change in that message. You could see why this would be great for signing some sort of an email, right? Because you sign it, that hash is very sensitive to any change. All I did is change the capital P to a little p, and this is completely different. Okay, so we really only need one of these two here to do our homework questions. So I'm going to go ahead and just get rid of this top code so that we can try this out. So let's say that the question asks you to get the SHA-256 hash of the word Bitcoin. You see what I changed? I'm only changing the stuff inside the quotes. And when I hit run, that is the SHA-256 hash of the word Bitcoin. We can't take this and work backwards to Bitcoin. That's why this is what we call a one-way hash. A one-way hash. So I'm sure that if we looked at the homework, there's probably something there for us to take a hash of. So let's just go look. So assignments and exam. Not sure if it's in Bitcoin or the regular homework. I'm going to try the Bitcoin stuff first. Okay, right here, my question 12, it says compute the SHA-256 hash of the string being stored in the variable sentence. The sentence is Ken Clifton. So if I just copy that, the stuff that's inside the quotes, and go back to Tani, and right here where I had Bitcoin, if I paste that in, you see I need to get rid of that. Okay, so here's my sentence now, is Ken Clifton. When I hit run, this one line right here without any blanks, remember, it's a fill-in-the-blank question, so you got to be very careful. If I run this, you can see if I copy this to my clipboard, Control-C to copy it. I come in here, and there's my fill-in-the-blank, and I do a Control and V as in Vicky. Paste that in. Let me make sure there's no leading blanks on it. There's not. So this is the answer to that question. Now notice I only pasted one thing in. Remember when we were doing this, there were actually two lines doing the same thing. Remember when I ran this program, I had taken all that other stuff out, so I only get one hash. That's the way you can compute a SHA-256 hash, and that's the way that you can answer your homework questions here. Okay? So let's go back and talk more about Bitcoin, cryptocurrency in particular. Now, you need to watch this video, and that will give you some of these advantages. Okay, now let's talk about this from the perspective of the folks that are in favor of cryptocurrency. When you send money to somebody using a bank, they charge you a wire fee to send that money. Okay? Bitcoin does charge a fee, but it's usually less than what the bank would charge to send that money. We can send it to someone in any country. And if you've ever heard of somebody having their wages garnished or the IRS taking money from their bank, confiscating their money or freezing their bank accounts, Bitcoin cannot be frozen. So if you have money in a Bitcoin wallet, it can't be frozen, it can't be garnished. So you have control over that. Another interesting thing about Bitcoin takes us to this distributed communications network. Bitcoin uses this model here on the right where I'm pointing with the mouse. That's a distributed communications network, similar to what the internet or the World Wide Web uses. And so if you think about this, the whole idea behind the World Wide Web or the internet was DARPA, the Defense Advanced Research Projects Program, came up with the idea of the internet to protect against an atomic attack, where a large portion of the country might be wiped out. If we were using a model like this decentralized or this centralized model, and this point in the middle was taken out by an attack, then nobody could communicate with anyone else because it all had to go through this point. Same way here, even with decentralized, if this middle part of the network was taken out or taken down or whatever, then if we're sitting out here at this point right here or up here, we couldn't talk to each other because this is gone. When we have a distributed network like this, it doesn't matter if we take out the middle part of this because there's all kinds of ways that we can still communicate. So Bitcoin, the blockchain itself, is spread all over the internet. So no one person controls that. Now think about that from a money point of view. The first thing that happened back, throughout history, when a king took over another country, when they conquered another country, the first thing that they did was they forced everybody in that country to adopt their money system, their coins. Why do you think that they would do that? The first thing, they'd make that other country adopt their coins. If you control the money, you control everything. So, Bitcoin is designed to prevent that. I'm sure you've heard of other countries like Zimbabwe and other countries where their money basically went to nothing, where they were having to take suitcases full of money just to buy a loaf of bread. If you tried to leave the country with money, they had currency controls on it. So you were stopped at the border and couldn't leave. So with Bitcoin, as long as you know the password to your wallet, you could have that wallet somewhere in the cloud. As long as you know your password, you could leave the country with nothing in your pockets and go to another country and still have all of your savings. So that's a good example of why folks are interested in Bitcoin, to keep governments or other actors from confiscating their money. And so, why is the blockchain so interesting? Well, it has implications for other things. Why do you have to go to the Register of Deeds to get a deed to property? Well, the lawyer writes the deed to the property out and everything. So why does it have to go to the Register of Deeds? It has to go there to be recorded. And the Register of Deeds puts their stamp on it saying it's valid. Well, the blockchain, which just happens to be used by Bitcoin, is a special type of a list where each time we add a new link to the chain, we take the hash, remember that SHA-256 hash that we just computed? We take the hash of the new block, but also everything that was in the chain before that. So once we compute that hash of the block and everything that came before it, we use that hash as the link to the next link in the chain. So if we messed with anything anywhere back to the beginning of the chain, if anything was changed, remember how that hash just went berserk? Well, we're taking a hash of the whole thing every time we add something new to it. So that means that the whole chain is immutable. You remember from our strings lecture and also the list lecture, a string is immutable, means we can't change anything in that string once we make it. So with the blockchain, every time you add something new to the chain, it is made immutable by this hash. Now, where do miners come into play? The miners are out there all over the world trying to compute this hash for the next block that's going to be added. Anytime somebody needs to add a block to the chain, all these miners all over the world are out there trying to come up with this hash first. The first miner to come up with this hash correctly and then gets verified by all these other miners, they all say, yep, you came up with it. You had the right hash. That person gets a reward, a block reward. They mine some coin. Well, this concept could be used for, remember we said we wanted to have this deed to property and we wanted to record it. Well, if we recorded it on the blockchain and it's hashed, then it can't be changed. So that's the whole purpose of recording a deed, so that somebody can't change it. So it's locked down in time, and no one can change it. All they can do is add something else to the chain to, to give that deed to somebody else. You'd have to put another block on the chain. So this is huge. It has implications for everything, from your Register of Deeds, driver's license. You have to go to get a driver's license because somebody has to issue that. Your academic records, your student records, every time you take a class and you finish it, you get a grade. Well, that could be recorded in a blockchain, and it would be locked down in time. It could never be changed. It could only be added on to. So, medical records. I hope you're starting to see that this has implications for everything. And that's why we're talking about it in this class, is because it has implications that are endless, from medical records to driver's license to deeds to academic records. Anything that you want a immutable history of records for, that we certainly in our medical records, we wouldn't want something to get changed in there and have the fact that we were allergic to penicillin get removed. Well, if that happened and it was in a blockchain, the whole chain would disintegrate and we would know something was wrong because nothing would be there. So we'd have to go back to the last version of the chain, go back to get the one that finally the hash matched for. So that's a little bit about why we're talking about hashes. They apply to so much stuff with computers. That's also why we're talking about the blockchain, because that is a fundamental concept that is going to change everything, not just currency. And you can see right here, this changes. I put this in the lecture because you can see this change. It may be different by the time you click on this page in the course materials, because this is a live link. It changes. At one point, Bitcoin had gotten to be almost $20,000. It fell down to around 4,000, and it's back up to 7. So who knows where that's going? But the blockchain is a fundamental concept. The fact that nobody controls your Bitcoin except you is a fundamental concept. There's no one country that you have to worry about. If this country goes bankrupt, your money is worthless. Whatever country that might be, can't just print more currency and make your money that you have in the bank worth less if you have it in Bitcoin, because it's stored all over the world, and the value comes from how many folks are on this network and how many folks are using it. So there's all kinds of material that's been written. So you will be responsible for the material here in this video on Bitcoin and the blockchain. You will also be responsible for all these linked materials here on who came up with the concept of Bitcoin and how does the blockchain work and all this. So these linked items here in the references are all things that you will need to read and understand in order to answer the homework questions. So that's the end of this little lecture on hashes and Bitcoin, and I hope you have a great week, and we will be starting the next module after this week. So we'll be in the final module of the class on imaging. So good luck with Bitcoin and the blockchain and cryptographic hashes. Have a great week. Stay safe. Stay healthy.